Hello, once again, this is Mr. Wakefield, and we're looking at what we call solving a linear equation. Now, not all equations are linear. We'll get into that. If they are, we use these steps. And by the way, this is also referring to a one-variable linear equation. We'll also see two-variable linear equations. Those types of equations are ones where you usually put them on a graph instead of just solving them. Okay, for example, if you have an equation with both x and y in it, okay, that's a very common thing. But here in this video, we're just looking at linear equations that have one variable in it. Okay, so what makes them linear and why is that important? Okay, first of all, with linear equations, and I'll explain as we go through this here why it's linear so you'll know, because it's going to be important. But the reason why we need to distribute this out first is because it asks us to do this in a linear equation, and then we'll talk about why it's linear. What it means to use a distributive property to clear out any parentheses, that means that if you have a bracket with two terms in it, with a term in front of it that's being multiplied by it 3 times the bracket here, 3 times the parentheses, you distribute the 3, meaning you multiply 3 times x and 3 times the negative 4. Okay, so we get 3 times x is 3x, 3 times negative 4 is negative 12. And then when you do that, make sure that there's a plus or minus in between each of the two answers there when you distribute into two terms. So if this had been positive 12, you'd have to put the plus there. Just a reminder there. Make sure there's a plus and minus in between, depending on what the sign is. Since this is negative 12, we put the minus there. Now, if you have a term times a bracket, minus another term times a bracket, if it's set up like that, with the minus in the middle here, remember you have to distribute not just the 4, but the negative 4. Okay, that's the easiest way to do it. And so don't just distribute 4, but distribute negative 4 right here. Okay, negative 4 times x is negative 4x. Okay, and again, if that had been positive, you put a plus there. And then negative 4 times negative 2 is positive 8. And like I said, when you distribute to the two terms, you got to have, you don't just write down 8, you've got to write down a plus if it's positive, because just like over here, if you've got two terms that you distributed to, you've got to have a plus or minus in between the two answers when you do the multiplication twice here. Okay. Over here, there's no bracket on the first part right here, but if you have a polynomial, okay, like 2x plus 3, all right, polynomial again is just when you got regular terms being added or subtracted together, like 2x and 3 right there. Just a reminder of what, this is from a different video, what monomial terms look like, okay, where you have either just a constant number or a constant term times a variable with a whole number exponent, which could also be x to the first. Okay, so 2x and 3, those are a couple of normal terms are being added together. That's a polynomial. If you have a polynomial followed by a minus right behind it, and then there's no number. It's not like this one right here where it's minus 4 and then the bracket. It's just minus and then a bracket. When that happens, there's an invisible 1 right there in between the minus and the bracket. So what you do, just like with the minus 4, you're going to distribute the minus 1. It's just that the 1 is invisible, but it's still there. Okay, so you still got to distribute minus 1. Negative 1 times x is negative x. Okay, just like we wrote down negative 4x, we bring down the negative x when we multiply. Negative 1 times negative 2 is positive 2. Okay, put down the plus since it's positive. Okay, now what we have here is, and this is the whole thing about linear equations. Okay, if you clear out the parentheses on that first step and you end up with a bunch of terms being added and subtracted. See how we have 4 terms here with pluses and minuses in between them? Same thing here. So you have a bunch of terms being added and subtracted on each side of the equal sign. If you have that, and each term is either just a normal constant number with no variable, like negative 12, or if it's a constant number times x to the first power, if all the terms are one of those two things, either the constant times x to the first power, or if it's just a constant, with no variable, then that means, and this is assuming you've already cleared out the parentheses, when you get on that step, if it looks like that, it is a linear equation. Why is this important? Because later on, we're going to see an equation like this. This is not linear. Okay, this equation right here is not linear because it has x to the second power. Okay, you need to have regular monomial terms like I just reviewed with you there that are either just a constant number or x to the first power. Okay, not x to the second power. And so that's why we do these steps on this problem, but we would not do these steps on this problem that we'll see later because of the x to the second. Okay, so the key thing with linear equations is that you never see any x to the second or x to the third. It's always going to be just x to the first or no x at all in some of the terms. That's fine as well. So what is the second step now that we've established that it's a linear equation? It says combine like terms on each side of the equation. In other words, each side of the equal sign. So the equal sign is kind of like a separator right here. It's like a separating the two sides. So we combine the like terms on this side, and we combine the like terms on that side. So we can combine the 3x and the minus 4x. 3 minus 4 is negative 1, so that would be negative 1x. Same thing as writing negative x. The 1 can be invisible. And then negative 12 gets added to 8, and so that's going to be negative 4. Remember, when you're combining like terms, you got to have pluses and minuses in between your answer. Since it's negative 4, we put the minus instead of the plus. 2x and minus x, because those are like terms, you can combine those. 2 minus 1 is equal to 1x. 1 can be invisible there. 3 plus 2, those are like terms, that's positive 5, so we got to put a plus there to separate. Again, when you're combining like terms, you got to have pluses and minuses separating your answers for each part that you combine. Then what's the next step? It says repeatedly add or subtract equal amounts from each side of the equation until you have all the variable terms on one side and all the constant terms on the other side. Okay, I'm going to introduce some color here. You don't need to do that yourself. This is just to highlight what I'm talking about to make it easier to understand. Okay, these are the variable terms. I'm going to put them in red just to make it easier to see. The variable terms are just simply the terms that have the variable in it. Okay, when I say terms, again, it's those monomial terms that are being added and subtracted. Okay, those monomial terms. And so you can see that there's two terms on each side of the equal sign. Okay, two terms being subtracted here. Okay, and then two terms being added here. Okay, negative x and x are the variable terms because they have the variables in it. These two terms do not have variables in it. They are called constants. Okay, and so what you do is you need to what? You need to add or subtract the variable terms to one side and the constants to the other. Okay, it's got to be on opposite sides. You can pick which side the red ones go on, and you can pick which side the green ones go on, as long as they don't end up on the same side. So what I'm going to do is I could either add, remember you got to add what? It says add or subtract equal amounts. One thing I didn't mention up there is you got to add the opposite amount of what you're trying to move. So if I want to move the negative x over here with the x so it's on the same side, I would, since this is negative, I'm going to add x. If you add x to one side, though, you have to add it to the other side. Equal amounts. Okay? Equal amounts. And so that causes, when we combine, like, what we do is we combine like terms on this side of the equal sign and on this side. Those cancel. Okay? As that sometimes happens with combining like terms. Just leaves me with negative 4. And then over here we get 2x when we combine like terms. 1 plus 1 is 2. And then the plus 5 doesn't combine with anything. Now, we still have to move the 5 and the negative 4 together, but it's got to be on the opposite side of the side that you put the variable terms on. Since we move the variable terms to the right, I need to move the two green ones over to the left. That means I'm forced to move the 5. I can't move the 4 because then that means the green and the red were both moved to the same side, and that's not right. Okay, I need to move the 5 with the 4. Okay, and what does that give me here? Okay, let me move it over here just to make some room here. And so that's going to be what? The 5s are going to cancel right here. And you're going to get negative 4 minus 5 is negative 9 on the left-hand side. All you have left on the right-hand side is 2x. Now, this step is complete when after you combine like terms. We combine like terms after we add or subtract equal amounts here to make stuff cancel and stuff like that. You then have one variable term on one side, one constant number on the other side. See how we have that there? Do not do this next step until you have that. When you have one single variable term on one side, not 2x plus something or 2x minus something, but just a single variable term. And then you have a single term that's a constant term, no variable, on the other side. Okay, again, the variable term doesn't always have to be on the right-hand side. Okay, as long as the variable term and the constant term are separated, obviously, from each other, but they're on opposite sides. They're separated from each other. They can't be on the same side. Okay, so you could have the variable term on the left as long as the constant term would then be on the right in that case. Okay, because that could happen sometimes. All right, it all depends on which way you decide to move your terms. So in other words, I could have moved this x over with the negative x, and then I could have moved the negative 4 over with the 5. If you had done that, then this is what you would have ended up, and you don't need to write this down, but you would have ended up with this equation right here. It looks a little bit different, but it's going to give you the same answer as this. Okay, so that's what's important, is it's still going to give you the same answer. Does not matter what side the variable is on as long as it's not on the other side. Okay, then the last step is to divide each side of the equation, not by the negative 9. You've got to divide by the coefficient of the variable term. Okay, and so that would be 2, wouldn't it? Because that's the coefficient of the variable term. If that had been negative 2, you'd divide by negative 2. Okay, the 2's then will cancel right here. Okay, and remember that when you're dividing terms, if it's just a single term by a single term, here's an example from a different video. Let me just look at this fraction right here. Okay, if it's a single term by a single term, you can cancel those if that's possible. Okay, by dividing by a common number there. Okay, since the 2 and the 2 are the same, here we divided by 5. Okay, to make it 10 divided by 5 is 2 and 5 divided by 5 is 1. Here we divide both of these by 2 and you get 1x over 1. But 1x over 1, anything over 1, you don't need to write that. You see, you can this can just disappear on the bottom. So I just end up with 1x. 1x is the same thing as x. So that's why it just becomes x. Over here you got negative 9 halves. Okay, you could put the negative on the outside there. When you have negative on the inside divided by positive, you could put the negative on the outside, because it is negative overall. Why am I done? Number one is because I did the last step. But number two, the goal when you're solving a one variable equation is to get the x by itself. What does that mean exactly, to get the x by itself? It means that it's 1x. Okay, negative 1x doesn't count, you guys. Even if it says negative x, that's not enough. It's got to be just x on one side of the equal sign. And then the x can't be over here. Okay, otherwise you haven't truly solved for x in that case. So if x is by itself on one side of the equal sign, just x, not negative x or negative 1x or whatever, okay, and then you have no x on the other side, but just a constant number, that's when you know that you've solved for it, okay? So let's try problem B right here. Very similar. When you got a term times a bracket, with the two terms in it, you distribute that through. The plus 3, that's not being multiplied by anything, so you just bring that down. Okay. X minus, now notice here, this is kind of interesting where it's just a term minus a term times a bracket. When you have two terms being subtracted right here, x minus 3, but they're not in a bracket, but it's just pushed up next to the x plus 1. You can see how it just got pushed up to the x plus 1 on next to it there. Just the closest term gets multiplied by the x plus 1 when you distribute. But just like with the negative 4 here, if that closest term, and again, this is if there's no bracket on the x minus 3, you would just multiply that closest term. But if that closest term is negative, you don't just distribute the 3, you distribute the negative 3, just like I distributed negative 4 over here. So we get what here? We get x minus 3x, okay, minus 3 times x, and then negative 3 times 1 is negative 3. And we got the same situation as we have over here. We now have, after we clear out the parentheses, we have a bunch of terms on each side of the equal sign. They're normal terms, okay, normal monomial terms, but they're just x, right? You don't see any what? You don't see any x to the second or x to the third or anything like that. It's just x along with some terms that don't have any x's at all, okay? When you have a polynomial on each side, just again, monomial terms being added and subtracted, and it has that effect where there's no x squareds or x to the thirds or anything, okay, then you know that it's a linear equation. So let's jump right into the rest of these steps right here. We already did the first one. Let's combine like terms. 2x doesn't combine with anything, but the negative 2 and 3 combine. Remember, only keep the two sides separate here on this step. Okay, the equal sign, don't try to combine the 3 and the negative 3, for example. Don't do that. Okay, you gotta, on this step anyway, you gotta keep the two sides separate. Here we got negative 2x combined in the first two terms on the right of the equal sign. The negative 3 doesn't combine with anything. And then once again, after we do that step, we then take inventory here of what our variable terms are. Okay, you don't need to, again, use color. I'm just highlighting this for you. Okay. We need to move the red ones to the same side, and we need to move the green ones to the opposite side. Again, you could choose which side is which. This time, just to be different, I'm going to move the variable terms to the left-hand side, unlike in the last problem, just to really reiterate that you can choose what side the variable terms go on. So because this is negative 2x and I want to move it, you have to add, you have to do the opposite thing. So if it's negative, you've got to add it over, so it will cancel. If it had been positive 2x, you'd subtract, just like right here with the positive 5 we subtracted. So we're going to add 2x to both sides then. That gives me 4x over here plus 1 when we combine like terms over there on the left. On the right side here, these cancel. We're just left with negative 3. So now I still need to move the 1 and the 3 together, but because I moved the red ones to the left, I have to move the green ones over to the right. That means that the 1 is the term that has to move. The negative 3 stays where it's at. Because it's positive 1, I need to subtract. Okay. So the 1's cancel there. Let me move it up here. And I'm going to get what here? I'm going to get 4x. 1's cancel. And then on the right-hand side, negative 3 minus 1 is negative 4. And now that you have a single variable term on one side of the equal sign, again, it doesn't matter which side it is. And then if you have a single term that doesn't have the variable and a constant term, in other words, on the other side, just a single term though, then you are now ready to do the last step, which is to divide. What do we divide by? 4 or negative 4? 4 or negative 4? Remember, it's the coefficient of the variable term, so don't do the negative 4. That's not the variable term. Okay, 4x is the variable term, so we divide by 4. And then just like over here, the 2's cancel. You just get x. Same thing here. The 4's cancel. Okay. And you get just x. Okay. And then negative 4 divided by 4 is negative 1. X is by itself. X is not on the other side. You have successfully completed solving this one variable equation, and in particular a linear equation. Now these last two problems, you guys, are a little bit special. Okay, we still do the same steps, but the result is a little bit funny and a little bit different, but we'll go through it carefully, don't worry. Okay, let's just go ahead and let's pretend like we don't know that that's going to happen. Let's just go through the normal steps, okay, and then we'll talk about how to deal with this unusual thing that happens. So the first thing we do is to realize that we got to clear out our parentheses by distributing out the 7. There's nothing to distribute over here because there's no parentheses on the left side of the equal sign. Distributing the 7, we get 7 times x and 7 times 1. And then the minus 3x is separate there. Okay. Notice that when you have a term times a bracket and then the bracket closes up, you don't ever distribute to the to what's after that. Okay, so that's why you don't do 7 times negative 3x. It's just the 7 times the bracket. Just like here, 3 times just the bracket. We didn't do 3 times the rest of the stuff over here. Just 3 times that bracket that it's right next to there. Okay, and so that's why you just bring the negative 3x down. You don't multiply by anything. Now we combine like terms. Something interesting happens here. The two sides end up looking identical. So you might be wondering, wow, what's going to happen with that? Well, again, if you're not sure, that's okay. All right, let's just keep on doing the normal steps, and then eventually we'll know what to do. Okay. So you just collecting my variable terms and constant terms. I move the variable terms to the same side. And here's what's interesting. They both cancel. Both of these cancel. And now all that we have left is 7 and 7. Okay. If 7's the only term that's left, you don't need to write plus 7, although it's not going to hurt if you do. Okay. If it had been negative 7, you got to write the negative. But if it's just a one term and it's got a plus in front of it, you don't need to write it when it's just one term. The plus there would have to be written if the 4x was still there, though. But here's what's interesting. The variable is gone. It disappeared. And in this time, it's not one of those situations where it's invisible. It is not invisible. It literally went away. It's gone. And so remember, the goal in the first two problems was to get the variable by itself. You can't get the variable by itself if it disappeared and it went away completely. And so here's what we do. Okay, when the variable disappears and you get a, let's write this down. When the variable disappears and you get a false, pardon me, this is not a false statement, this is a true statement. I'll show you why in a minute. When you get a true statement, here's why it's true. 7 equal to 7, that's a true statement, right? If I told you that 7 was equal to 7, I would be telling the truth, right? If it had said 7 equal to 8, now that would be a false statement. So if you get a true statement, and sometimes you will get a false statement, as we will in the next problem, so I'll tell you how to handle that. But if you get a true statement, then the answer is what we call all real numbers. So let's circle that. All real numbers. Circling that right here. Okay, that means that every single number, every single real number in the world, we'll see other things like imaginary numbers later. Okay, but all real numbers, which is basically all the whole numbers, all the negative whole numbers, all the decimals that you could possibly think of that are in between those numbers. That's pretty much, if you imagine all of those numbers, that would be the entire world of real numbers. All of those numbers are solutions to this equation. What makes something a solution to an equation, by the way? Something is a solution to an equation, and you don't need to do this, by the way, but just to show you, okay? Later on, sometimes you'll need to, but not in these problems. But -1 is a solution to this equation, because if you were to plug -1 into the x's right here, and then figure out what the left side of the equal sign is equal to, and you figure out what the right side of the equal sign is equal to, it would be the same. It would be E equal. It would be true. Okay, just like 7 and 7 are true. Okay, so if I plug in -1 right now, it would make this side of the equal sign and this side of the equal sign equal to the same thing. Again, it's not mandatory for you to actually check to make sure that happened. If you did all your steps correctly here, that should already be automatically true, so you can confidently declare that -1 is your answer on that problem. But in this case, every number in the world, all real numbers anyway, are solutions to this equation. Okay. Now, how about an equation where there's no answers at all? No solutions. That's going to happen here. Let's distribute and do our normal steps. Okay, distribute out the 4. And you'll see here that there's no like terms to combine. Sometimes that happens, so I'll skip that second step that was up here at the top where you had to combine like terms. You don't need to do that step here. We need to put the red ones on one side and the green ones on the other side. By the way, you might be wondering, why did we stop right here? The second that the variable disappears, you can stop. You don't need to do the rest of the steps. In a lot of cases, you can't, especially because there's no variable. So that's why I stopped. Speaking of that, we're going to be, this one's going to stop real shortly here as well. I'm going to move the 4y to the same side here. Let me move them both over to the left side. The 4y's cancel, both of them, just like in the last problem. The variable terms cancel completely, and we get 20 equal to 21. So you see what happened here? Once again, the variable disappeared, just like in problem C here. The only difference is that we now have a false statement. If I said to you 20 is equal to 21, you would say, no, 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 that's false. Okay, so this time it's false. So if the variable disappears and you get a false statement, if you get, and I made the arrow right here because this is also a problem where it disappears. Okay, if you get a false statement, then the answer is no solution. Please remember, you guys, you can't just say true or false is your answer. That's not the answer. You got to tell me what the solution is. So if there's no solution, you got to say those 2 words. If it's all real numbers, you got to say those words. Okay, and if the variable does not disappear, you will always get, at least with linear equations, you will always get one answer. Here it's -9/2. Over here it's -1. So there's 3 different possibilities when you're solving one of these one variable linear equations. You're either going to get one answer, like we did in the first 2 problems, or the variable will disappear and you get one of these other 2 possibilities. Okay? So that's solving one variable linear equations. Please remember that, like I said, when you have x squared or x to the 3rd in your problem, something like that, the method will be different. Don't worry, we'll cover that carefully eventually. But for right now, if you clear out the parentheses, not that there's always going to be parentheses at the beginning of the problem, but if the parentheses are cleared out, whether it's at the beginning of the problem or if you have to do that step, if you get an equation where it's just a bunch of monomial terms and you only have x, you don't have x to the 2nd, x to the 3rd, you only have x's, okay, along with maybe some constant terms like -12 and 8, that's a one variable linear equation. Okay. And so that concludes our discussion on linear equations.